All right. So we did a ton of stuff last Thursday. And so just to kind of remind you where we're at, we are talking about inheritance. And we're talking about designing these hierarchies of classes. And so you're designing classes for the Homework 3 project, and those are making individual objects, and inheritance is how we can link them together to say that these classes are related in some way. And so with that, I'll make it so that I can actually draw. So with that, we can draw these hierarchies. And so last time where we ended off, we had some shape class that has some methods that I want every shape to have. I'll open Eclipse so we can see that code. And so we made this, so that's not a shape. So we made this class shape, and I want every shape to know what's its perimeter to be able to return that, what's its area, be able to calculate and return that, and what's the semi-perimeter. So these are things that I want every shape to have. And so with inheritance, I can have a circle class, and the circle inherits. Here's what a perimeter is. If I make a rectangle class, it's got length and width. And so that allows me to go on and make a square class later on. And so then I don't have to define what length and width are. I can just say, hey, length and width have to be the same, right? So with inheritance, there are things that I inherit. So I inherit fields and methods, and I've got to define my own constructors, but I inherit some members from the superclass, and then I don't have to worry about those. So that's inheritance, and so we can have a circle class, we can have a rectangle class. We can also have a square class later. And so we read this diagram with the more general things at the top, more specific things at the bottom. And with this line that we draw between circle and shape, we can say that a circle is a shape. So is a. And we can say that a rectangle is a square is a rectangle. A rectangle is a shape. And through the transitive property, a square is a shape, right? So we can draw this diagram, and the way we do that is with the word extends. And so here we have rectangle extends shape. And that tells us that a rectangle is a shape and it inherits things. And so we can see that through the UML diagram. Currently, we're only selected rectangle, and so shape doesn't populate. But if we go into our packages, and so if we select both rectangle and for me, I hold the command key, or on Windows, you would hold the control key. And so if I select both of those in my package explorer, then shape populates as well. So that's great. And so with this arrow, we see that a rectangle is a shape. Let's make a square class really quick. Square, and I want it to be, I want a square to be a rectangle. So square extends rectangle. Inherited abstract methods. And let's make a constructor. So here's the thing, like a square is a rectangle. And the only thing that makes it different from a rectangle is that the length and the width have to be the same. And so let me actually do the right click and then source, generate constructors from superclass, because we wanted to use what the rectangle is. And so we can do that. Okay, one problem could be that we could be given something that, so like theoretically we could be given square of 3 and 4, and we don't want that to have happen because then that's not a square. Because we really only need one parameter to define a square. Like we need one number of how long are the sides. And so my idea to kind of get around this method square double double is undefined for the type square. Okay, this was my initial thought. Okay, now the word square is losing all meaning to my eyes. Have I made a typo somewhere? The method is undefined for the type square. So maybe I have to make it public. In which case, it doesn't like that. So, yeah.
No, why don't you just do super side side?
Great. Okay, that works. And so that means that I don't need to have this constructor. So if I restrict it to only one constructor, then I bypass the possibility that someone gives me a square of length 3 and width 4. Thank you. Sometimes like, so during the summer research program, there are these like professional development days. And one of the days was about like getting up and talking in front of people. And one of the things that Professor Lee said was that like when you get up in front of people, you're automatically like 40% dumber, which I will guarantee you is true. Like I can't do mental math when I'm standing in front of class. So thank you. Appreciate it. Okay, so other than that, do I need anything? I don't think so. Like all the other important stuff is handled in rectangle. And so now so let's look at our diagram. So I'm just going to select the package name and move this up. So shape, that's weird. Shape's not abstract in this one. What if I select these all? Okay. So that fixed it. So the problem is if I just click on that, it doesn't say that shape is abstract, which is untrue. But if I select the files, then it shows up correctly. Okay, and so just a reminder that in the UML diagrams, we have abstract methods, which are when we don't want to define any implementation, which is important for shape because shape is a super general thing. I can't actually make a shape object. Like that doesn't make sense. There's no quantitative things that I can use to say this is a shape. I have to be more specific later down the line. And so because of that, I can make this method abstract. And so that involves me just saying, here's the method signature, stick an abstract in there, semicolon. And that means I want every shape to be able to say what their perimeter is, but I don't want to say that here. I don't want to say what that looks like for a general shape because it's going to change. Same for area. The way a rectangle computes its area is different from the way a circle computes its area. That difference is too broad. I don't want to prescribe, here's how that should happen. So I make it abstract. Only for a method that I know what it's going to be can I define implementation. And so this is never going to change, so I made this method final. And so I can have that. If a class has at least one abstract method, that class must be abstract itself. Because if I can't have a class that doesn't know how to do one of its methods, right? If I have a class and I make an object of that class, then I have to know what all the methods are. I can't have like a giant question mark in there. And that's what making something abstract does. So once this is abstract, then the whole class must be abstract. All right. So that's kind of a review of what we talked about yesterday. We talked about final methods when when the implementation of a method will not change over the hierarchy. We talked about abstract methods where the base class provides no implementation, just a signature. And then later down the hierarchy, we have to provide the implementation or be abstract itself. Static methods when we don't have a controlling object, and then everything else. So let's talk about interfaces. So we have our shape hierarchy, and let's talk about stretchability. And so this is kind of like if I have a rectangle, I could treat it kind of like silly putty, you know, and just like stretch it out. Or if I have a circle, well, I can't make it into an oval because then it's not a circle anymore. But I could like, if you actually, let's insert a circle. Okay, so I have a perfect circle. Great. I can stretch this circle. So that makes it not a circle anymore. But I can do this, and then what's changing there? Yeah, so the radius of the circle is getting bigger. Okay, back to the slideshow. Right, so the radius increases. For rectangles, I could either make it longer or make it taller. For squares, it can be similar where we go from a small square to a bigger square, right? So we can stretch shapes. And so when we talked about like the beverage example, nope, I exit out of the drawing. So when we talked about the beverages, we said like some beverages are carbonated. So like Coca-Cola, Sprite, those are carbonated. So are bubbly and San Pellegrino, right? Even if bubbly and San Pellegrino are like, if we consider those separate from like soda, like Sprite and Coca-Cola, all of them are carbonated. And so we have this is sort of relationship. So before we're talking about the is a relationship where we can say like a square is a rectangle. We can also say like is not a. So like a circle is not a rectangle. And so we can see that because we can't go like going up in the diagram, we can't get from circle to rectangle. We can't get from square to circle. Whoops. And so we've talked about the is a relationship, and now we'll talk about is. So like a circle is stretchable. A rectangle is stretchable. We just have to define what that looks like. And so something we'll see in the lab are we've got employees and they are payable. And so this is where interfaces come in. Because we kind of want to have it both ways. So let's say we're back in our student employee hierarchy. So we've got a student and we've got an employee, and both of these are persons. And so let's say you get a work study job grading for the math department. Then you could theoretically be a student employee where you have an hourly wage and you also have a GPA because you're still a student. And so I have the answer here, but it seems like it should work, right? Like we should be able to take both things. But the problem is here is Java doesn't allow multiple inheritance because there's the capacity for conflicts. So this is probably fine because both of the student and employee get their information from person. But maybe if employee was something else, like maybe you've got a job at, I don't know, Taco Bell or somewhere, like they have a different way of maintaining all of their data than St. Mary's does. And so if you got their information, it might be stored in a different format than the way that St. Mary's stores the data. And so that's a problem because too many conflicts can happen. So, and it could be something wildly different. So I didn't think of this ahead of time, but like maybe the initials GPA stands for something else at the company that you work at. And then that's a problem. If we have like a double GPA and they have something called GPA, that can't happen. We don't want that to make problems for us. So because of that, multiple inheritance is illegal in Java. So the way we kind of get around that a little bit is with interfaces. And so we're going to write something that looks a lot like a class. An interface is not a class. Repeat after me. An interface is not a class. Is an interface a class? Are you sure? That is correct. Okay, so I'm going to make all my shapes stretchable. So I'm going to write a stretchable interface. So I'm going to go to my new menu and okay, interface. It's not a class. It's a separate option, interface. And I will say stretchable. I've got modifiers for its visibility. Interfaces can extend other interfaces. So in case we want to have some inheritance going on there as well. But I will finish. And then it takes me to something that looks a lot like a class. In fact, it's got the .java file type, but instead of public class stretchable, it's this public interface stretchable. And so with this, an interface is going to be, it's kind of similar to like an ultimate abstract class. But is an interface a class? Correct. An interface is basically a method contract. A contract in the sense of so let me think. Okay, so I know the guy who manages the chapel, and he had the windows replaced in the chapel over the summer. And what he does is he reaches out to people who can perform this work, and he has a list of things. Here's what I want you to do. And then the contractor goes to those things, says, yep, I can do them, checks them off the list. right? So for an interface to be a method contract, we say, here's a list of methods I want to have implemented. And then any class that uses that interface has to implement those methods. Okay. Repeat after me. An interface is a method contract. Is an interface a class?
Yeah.
What is an interface? Great job. Probably. So implicitly, the methods that we're going to give them are all public and abstract. And so if I want my method to be stretch, I'm going to say, I can leave out the public abstract and I just say the method, the return type is void because I just want you to do it. And it's going to be called stretch, and I will give you a factor to stretch by. That's my interface. So implicitly public and abstract. And it's abstract because I don't provide any implementation. I just have a semicolon. You can have some default methods to say, like, at the very least, do this. You can have static methods. All declarations in an interface are implicitly public. It can also contain fields and variables, but those are implicitly public, static, final. And so when you take all that in, you start to think, this sounds kind of like an interface as a class. No, don't be fooled. Especially because the fields, since the fields are public, static, and final, classes don't have that restriction, right? Classes can have fields that aren't public, static, and final. They can have private, non-static, non-final fields. Right. Is an interface a class? I think it might be. No, it's not. Correct. All right. So we've made our interface. How do we use it? We use it with the word implements. And so, for example, we're going to be using the lab where we have an employee class. An employee is payable. And so we say public class employee implements payable. And so let's say later on we decide to make an intern class. And so an intern is an employee, and that intern class implements payable. Okay, so let's put this in here. And so let's say I want every shape to be stretchable. And so here's where we get the is relationship. So stretchable, is stretchable a shape? No, stretchable is like, what is that? An adjective? It's an adjective. It is not a shape. A shape is a noun. And so like a stretchable isn't a square too, right? Like that doesn't make sense. And so this is where that is relationship comes into play. And so we can say, all right, I want every shape to be stretchable. You may have noticed that this causes problems over here. Now these have errors in them. Let's see what that is. Hover over it. The type rectangle must implement the inherited abstract method stretchable, stretch double. So stretch is an abstract method, and rectangle is not abstract. And so that means that I have to implement stretch or make square abstract, or make rectangle abstract. One day, I will get the difference between rectangle and square. And so here I'm going to add unimplemented methods. And then if I scroll down, here it is. And so to stretch a rectangle, because I want to kind of think carefully about this because rectangle also has square depending on it. And so I could choose to do something like length times equals factor and let that be it. But that's going to create problems for me in square, maybe. And so maybe I want to make that change for both of my dimensions as well. This is a decision that I just made. I could have made a different decision. I could choose to only stretch the length, and then down in square, I redefine, hey, here's what stretching means to me, right? This is a decision I just made as the programmer. And then similarly, we can make this in circle. So hover over that, add unimplemented methods. The other way to get that is if I right click and go down to source and I think override implement methods. And then it pops up of here's the ones that you forgot. And so that's from stretchable. The method is stretch. So I can click OK. And it puts it up there. That's fine. The order of things in the class doesn't matter. It's mostly what makes most sense to you as the programmer. And so for stretch, for a circle, we want to increase the radius. So it's just radius times equal factor. And that's how we use an interface. Let me show you. So let's say we were going to go create a new class. Someone have a favorite shape? A diamond. Let's see, how is a diamond defined? So it's a sideways square. A rhombus. How's a rhombus defined? Diagonals. Tell you what, let's maybe go with triangle. And so if we would go to create a triangle, let's do so a triangle, is it a circle? No. Is it a rectangle? No. So it's just going to be a general shape. And oh, look, now we have options that we understand. So we've got our source folder, our package. Here's the name of the class. Here's the visibility modifiers. We can say whether or not this class is abstract, whether we want it to have abstract methods. We can say, here's the superclass. We can say, here's the interfaces. And so we could manually add stretchable at this point. However, when we have inheritance, stretchable, like the methods from stretchable follow it. So like when we implemented it in shape, the classes that are below shape threw up errors. So it gets inherited. So we can add interfaces. We can add a main if we want. If we want to generate like the constructors that the superclass has, we can do that. And it'll just give us boilerplate things. Do we want to implement? Do we want to bring in the inherited abstract methods? And do we want to generate comments? So now's the point where we know what all of these things are. So remember on the very first day, I was like, just type the name in here, click main. We'll worry about that later. It's later. We know what's going on here. Hooray. Okay. We got to get to the lab. So I will not actually implement the triangle class. Okay. Is an interface a class? Are you sure? Really, really 100%? Maybe not that extreme. So an interface is just a list of method signatures. An interface is a method contract. Any class that implements this interface must provide the code, so curly brackets, and here's what happened, or else the class is abstract. Here's a question for you. Let's say I have an abstract class. Do I have to have abstract methods in there? So I have an abstract class. I've got many, many methods. Do any of them have to be abstract? So here's the thing. So if I have an abstract method, the class must be abstract. But the other way around doesn't hold. I can have an abstract class and have no methods. For an abstract class, I'm just wondering, am I going to be making an object out of this? If the answer, so like, am I making a shape? If the answer is no, then I can make that class abstract. Okay, talked about that. So if I want, so let's say I have some configuration. I've got B and then A extends it, and then A implements some interface. I can do that. And so it says A extends B implements C, so the interface comes after. And then I have to implement the exact method that the interface says. So, like, I can't misspell stretch, or I can't change the type to an int, right? It has to be exactly what's in the interface because it's a contract. Like, if I send out a contract to make repairs and you make only 3 out of 5 and then the rest you're like, you're not going to notice. That's not according to the contract. You can have multiple ones if you want, just separate them by commas, and then you just provide all of the implementation. And that relationship holds. So coffee isn't carbonated, but Sprite is carbonated, right? So as you're drawing that diagram, you can draw interfaces to help you out with that. In terms of no-nos, you can't reduce the visibility of an interface method. So by default, they're all public and abstract. So you can't go and make this private. You cannot reduce the visibility of the inherited method from stretchable. So it's like, nope, can't do it. And you can't use two interfaces which have the same method signature and incompatible return types. So if I have one method that's a return type of void and the other has a return type of shape, so maybe like I'm going to stretch and return a new shape. You can't implement both of those in the same class because the compiler doesn't know how to resolve that conflict. You can extend other interfaces, and the interface information is inherited throughout the hierarchy. Okay, fundamental inheritance, we've talked about this. Java.lang.object is the implicit superclass for everything. So even if we have shape kind of up here, in order to make this work, Java has this capital O object type that it makes every other base class implicitly inherit. So a shape is an object, right? And we see that when we go to make, no, not interface. We see that when we go to make a new class, where if we don't specify the superclass, then by default, it's java.lang.object. And so that's also where we get the original toString of here's the package, the type name, and a string of letters and numbers. That's where it inherits from. All right. I'm only a little bit behind schedule. All right, so let's do lab 5. And lab 5 is over here. So this one is super fun. I love this lab a lot. Let's look at the diagram. This diagram will be your best friend as you complete the lab. So similar to lab 4, when I gave you a diagram and you're looking at all of the, like, you're implementing it according to that diagram, you're doing the same sort of thing here, except there's a lot of classes. So I provide most of the classes, but they're just empty. And so it's your job to implement them. And so things to remember are what is the, like, what do the red squares mean versus the green circles? Abstract methods are italicized. And so that tells you that we've got get gross pay, that's italicized. Employee has to be abstract. And so we're building this, like, we're building this payroll system for our company. And so we've decided that, okay, we're going to have employees. We have employees, people who work for us, and suppliers, people who bring things to us. And so we have to pay, but they don't technically work for us. They work for an external company. And so we have employees and we have suppliers. Both of these entities are payable, right? So I can pay money to my employees, I can pay money to my suppliers. And so payable is an interface. It has get net pay. And so this get net pay gets implemented all the way throughout the hierarchy. So let's look at supplier. Supplier has a company name and the amount that we have to pay them. And so we'll have a constructor and then get net pay. An employee has all of these fields, their ID, what's their name, what's their title. Again, so with lab 4 and now, it's super picky about the spelling and the exact types that things has to be. And so be very careful. So these are just mostly getters. And then we've got 2 main types of employees. So we've got hourly employees, people who have an hourly wage. And so you input, here's how many hours I worked this week. And then you get paid that amount of hours times your hourly wage. And so there's an hourly pay rate and hours worked. And so from there, you can say, okay, here's your gross pay. There are 2 types of hourly employees, one of which are permanent staff, and the others are temporary workers. So maybe staff who work the whole year versus people who only come and work for the summer. And so staff have a tax rate. And so for get taxes, you have to reduce the gross pay by the amount of taxes. And temporary, I believe, has like a fixed tax rate. I'll show you where that table is. For salary employees, they also have a tax rate. So they have a get taxes method, but their pay is calculated differently from hourly employees, where they have an annual salary. And so that doesn't depend on the number of hours that they work. Okay, so I would highly recommend opening this in a new tab and going back and forth between the instructions and this image. Zoom in as much as you need to. Let's look down here. So these are all the information. This is the table that will be very helpful. And so here I have columns for what's the gross pay, how many taxes, what's the net pay. And so read through this super carefully and try and figure out. So I say, here's salaried, here's how it works for hourly employees in general. Here's how it works for staff and temporary. So in this case, for temporary, we don't tax them because they're employed through an external agency, and so they handle the taxes. Suppliers, we only pay their amount due. Any immediate questions? Great. So I will stop recording and we'll work on this for the rest of class. If you don't finish it by the end of class, I'll probably make it due next Tuesday. I ordinarily would make it on Thursday, but we don't have class on Thursday. So lab 5 for the rest of the class, and then we'll be good to go.